Is that a yes or no? No, no, nobody knows who she is. Moms Mabley was a comedian during. You should look her up. Go on YouTube, look her up or something like. She was a comedian. She was the first popular black female comedian to appear on mainstream TV. She was on the Smothers Brothers, Ed Sullivan. This is going back a million years. And, right, she's a comedian, and she was really hilarious. Whoopi Goldberg kind of grew up. She was one of her inspirations growing up to become a performer and a comedian. And just like this, she knew that people were forgetting who she was. She put together a documentary. I just saw it last night at the Tribeca Film Festival, and it's really an interesting film. And because she wanted to keep her memory alive, that this pioneer in her field wouldn't be forgotten. Her material wouldn't be forgotten because so many, like a lot of them performed on this black entertainment circuit that went from, you know, Alabama, Mississippi, all the way up to Philadelphia, New York, and Chicago, and so on and so forth, including the Apollo Theater. And a lot of her material was in this documentary. A lot of tapes and audio from her performances and stuff like that. And one of the things she said is that getting old is not that bad, but it's damn inconvenient, right? So when you see me stop doing stuff like that, it'll tell you that getting old is damn inconvenient. That's one of the inconveniences. But check her out. That Chitlin Circuit, right? Exactly right. Yeah, exactly right. So at any rate, that's one of the names that they had for it. Okay, so let's move on here. So what about our conclusions here? Do we reject the null hypothesis, or do we fail to reject the null hypothesis? Okay, why would we reject the null hypothesis? Did our z-score that we calculated, did the z-score that we calculated exceed our z critical? Our z critical was 1.64, right? For a one-sided test with an alpha of 5%. Did we exceed that? We didn't exceed it, right? And if I look at it on the graph here, what happened here was that the value 0.65 turned out to be over here instead of over here. So if there's no difference between playoff games and regular season games, we could expect to get this. If we took a random sample of 64, we could expect to get this result not 5% of the time, but possibly maybe 12% of the time, right? So we didn't prove to less than 5% chance of being wrong, or this isn't a rare enough event to say it would only happen less than 5% of the time if there was no difference from them. So we didn't go far enough across with our difference in order to reject the null hypothesis. We only went to a z-score of 1.17. Okay, does that make sense? Right, exactly, because the z-score didn't exceed 1.64. Now, we could, if we wanted to. Remember, on the test, you're not going to have Excel or SPSS, which on the lecture portion of the test. But now we have Excel here. And this value is our z-score. If we wanted to, in this case, or in both cases here, we could actually use a table or use Excel if we wanted to. Norm S dist, parentheses, norm S dist, and it's looking for the z-score, if you can see that there. The z-score is that. I'm going to hit enter, and we get a z-score of 0.87, 0.087. In other words, the area, let me go back here, this area to the left of this z-score of 1.17 is 87%. That leaves 13% chance of being wrong if we reject the null hypothesis on this side, right? So in other words, that means that that my p-value, my probability of being wrong if I reject the null hypothesis, is 13%. Okay, if this were a two-sided test, I would take that 13% and divide it in half because I'd be willing to use that half of that 13% on the other side as well on this side. But we're not worried. We're doing a one-sided test over here. On this one over here, or actually, I would double that if I got all z-squared. Because z-squared that big, I would double it because I would have to have not only 13% on this side, but 13% for a z-squared minus 1.67. Let me demonstrate that here with this test, because it was indeed a two-sided test. What's the p-value here? It's going to be equal to norm s dist parentheses and the z-score. That comes out to be 99.5, let's say. So that's 0.05. So that means that if I'm doing a one-sided test, that would be half of 1%, right? 1/2 of 1%. For a two-sided test, I know that I'm dealing with a z-score of 2.7 and a z-score down of 2.68 or something like that, and a z-score negative 2.68. I'd have to account for that too. So instead of just using the value, which I thought was 0.5% because this was 99.5, I would have to double it and say it's my p-score is 1%. Okay, a little confusing, I know, but as you work with this, as it starts to make sense, as you do more examples of this, it'll make even more sense to you. It'll make more sense to you. Okay, so now let's move on to the next problem. Okay, in this problem, we're dealing with what comes up more commonly, which is in real life more commonly, which is we're doing a study and we're studying two different things. Okay, so now we're testing an anxiety drug. We work for a pharmaceutical company. We're testing an anxiety, and we want to see if this drug works. So we take a sample of 200 persons, 200 individuals, and we give them the drug, and we have them report back in a couple of weeks their level of anxiety, and we put it on a scale, and we say that 64 out of 200 people reported anxiety. And we also took 200 different people, put them on a placebo. They're matched up somehow or other, same age group and so on and so forth. But they're not the same people. We put them on a placebo, and 92 out of 200 of those people reported anxiety during the test period. Okay, so now we know that means that the proportion of people that took the drug that reported anxiety was 0.32, and the proportion of people that took the placebo, the percentage that reported anxiety was 0.46. Okay, so now we want to demonstrate that there is a difference between the anxiety drug and the placebo, the percentage of people that reported anxiety. Okay, so I'm going to call this P drug, and I'll call this P placebo. Okay, so now I want to show what is my null hypothesis here. I'm not going to go back into the. You got me back. Sometimes I think, like this internet stuff is a little bit weird. Sometimes stuff will go on. You'll lose when you lose audio. What happens is that you're dropping packets of information on the internet. So if that happens to you occasionally, hopefully I'll be successful at recording this, and anything you miss, you'll be able to pick up later on. But usually it'll come back pretty quickly. And usually, like when you want to do this, try and get to a place where you have the best internet connection that you can. I know it's not that easy sometimes. I have a horrible one at work, and I just can't do anything with it. What is the simplest technique to identify one-sided test? Identifying one-sided test from a two-sided test. I hate to say this, but it's really how you read the problem. That's really what you got to look for. You got to look for keywords in there. For instance, that we're trying to prove that there's a difference, or they're trying to prove that there's no difference, or that we're trying to prove that one works better than the other. In this case, okay, the drug company is interested in proving. What are they interested in proving? They're interested in proving that their drug works. Okay, and what does that mean? They're interested in proving that P for the drug is less than P for the placebo. In other words, the P is the percentage of people that report anxiety. right? So they want less people on the drug reporting anxiety than from the placebo reporting anxiety. So what's our null hypothesis? That's going to be our alternative hypothesis. Right? I'm glad you brought that question up. You brought it up right at the right time there. So that because our null hypothesis, some of you already have are starting to put it together. Okay, our null hypothesis is going to be the proportion for the drug. I'm going to start with equals the proportion equals the probability of reporting anxiety for the placebo. Okay, but that doesn't cover all the possibilities. It doesn't cover the possibility that the placebo could actually be less than the have because I'm sorry, P for the drug is less than P for the placebo. Okay, is our null hypothesis. In other words, the proportion of people reporting anxiety is lower than it is for the placebo. So now if I use equal here, it doesn't include the possibility that the proportion for the drug could actually be greater than for the placebo. Maybe, some of these drugs, you read the warnings that they put on TV and stuff like that. And some of them that are intended as anti-anxiety drugs, that one of the side effects is that it increases anxiety in a few people, in a small proportion of people. So we want to make sure we cover all of the possibilities. So once we've decided that this is a one-sided test, we want to make sure that the null hypothesis, we have to reject both possibilities, that there's no difference, or that it's the opposite difference. Okay, so yeah, thank you, Katie. I caught it there at the last minute, didn't I? Yeah, every once in a while I'm getting people. It could be me. It could also be me and my connection. I'm hoping not, but that does happen every once in a while. Every once in a while I get somebody reporting no audio. It could be you, it could be me. No way for me to tell. Hopefully you'll come back, but keep telling me if that occurs, and if it continues to occur, let me know, because if it lasts more than a minute or two or something like that, maybe something more is going on. More than a couple of minutes, something else is going on. But keep notifying me of that stuff when it occurs. Okay, and okay, so now we have a conundrum here, right? We want to prove that that these two things are different. So now we have to. Before we were dealing with a sample that involved a single sample t-test. Now we deal with two samples. So now we know that since it's a single sample t-test, I'm not going to go back over this, but we know that our z critical for a single sample t-test, 95% confidence, is going to be equal to 1.64, right? So now because this is a one-sided test, right? Our Z critical is 1.64. Drug companies like one-sided tests because it makes it easier for them to prove that their drug works. If we were more critical, we would say, I'm not going to do that. I'm going to say they're different. I'm going to say it's two-sided tests. I'm going to make the company prove that it's 1.95. So we may not be satisfied with calling it a one-sided test, even though it really kind of is. But like I said, who's to say it can't be the other way too? Right? So that the drug doesn't cause more anxiety, and that maybe we really should do a two-sided test. We don't really know going into this. Now, the drug company could argue that, well, the way this works, it's a serotonin blocker or inhibitor or whatever way it works. They could argue that physiologically, the way that this works, it's impossible for it to increase anxiety. They could make that argument and back up their argument for using Z critical, but this is a little loose. This in real life they really should use 1.96, even if what they're trying to prove on paper is a one-sided test. Okay, just because that's a more rigorous test, especially with a drug or something like that. Okay, so now let's stick with the one-sided test just for our example. Okay, I think it's more appropriate to do a two-sided test because it's more rigorous. It's them.